Hello, viewers. Today we are going to start our lecture number 2 of Unit 1 Matrices and Determinants. Ninth class. I am discussing with you math of 9th class, science group. Mathematics of 9th class, science group, Unit 1, Matrices and Determinants. And here is the exercise 1.2. Question number 1. From the following matrices, identify unit matrices, row matrices, column matrices, and null matrices. This is the first one. A matrix whose all entries are 0 is called the null matrix. It has 2 rows and 2 columns. So if you want to describe it order ways, you can say that it is a null matrix of order 2. Here is another matrix, matrix B. You can see it. It has only one row. So this matrix can be called as a row matrix. It's a row matrix. As you can see, it has only one row. So this matrix C has only one column, so it can be called as a column matrix. Here is another one for you. Here it is. If a matrix has 1 in its diagonal, then it is called a diagonal matrix. But in the case if the elements in the diagonal are 1 only and all other elements are 0, this matrix is called the identity matrix. So matrix D is an identity matrix, which another name that we use for it is unit matrix. So we can call it a unit matrix or an identity matrix. Here this matrix has 0 as its element, so it is a null matrix of order 1 row and 1 column. So it is a null matrix. Here F has only one column, so it's a column matrix. So matrix F is a column matrix. Now we go to the next question. Here question number 2 says, from the following matrices, identify square matrices, rectangular matrices, row matrices, column matrices, identity matrices. Let's see. And null matrices. Here I have, for brevity, I have written whatever the matrix was under it. For example, this matrix has 2 rows and 3 columns. 2 rows and 3 columns. So the number of rows and the number of columns are not equal. If the number of rows and the number of columns are not equal, then the matrix is called rectangular matrix. Here there is only one column for this matrix, so it is a column matrix. Here there are 2 rows and 2 columns, so it is a square matrix. it has 1 in the diagonal and all other elements are 0, so it is a unit matrix or the identity matrix. Here there are 3 rows and 2 columns, so it is again a rectangular matrix. It has only 1 row, so it's a row matrix. It has only 1 column, so it's a column matrix. It has 3 rows and 3 columns, so it's a square matrix. And this is a null matrix because all the entries in this matrix are 0, so it is a null matrix of order 3 by 2, 3 rows and 2 columns. Now we have question number 3. From the following matrices, identify diagonal, scalar and unit matrices. If the elements in the diagonal are same other than 1, such matrix is called scalar matrix. This matrix has only elements in the diagonal and all other elements are 0, so it's a diagonal matrix. Here again in the diagonal there is only 1 as an element and all other elements are 0, so it is an identity matrix or unit matrix. Here again the main diagonal has some element in it other than 0 and all other elements are 0, so it's a diagonal matrix. Here 5 minus 3 is 2, 1 plus 1 is 2, so these two elements are the same then and all other elements are 0, so it's a scalar matrix. So what I just said I have also written here. I told you about A and E, these are the scalar matrices. A has 4 in the diagonal and E has 2 in the diagonal, so A and E are scalar matrices. Now unit matrix is C. You can see that in the diagonal 1 is written and all other elements are 0, so it's a unit matrix or identity matrix. And if we are finding diagonal matrices, so all the matrices are actually diagonal matrices because in the diagonal elements are written and other elements are 0. Only the elements which are present other than 0 are in the diagonal. So in a way we can say that all the matrices are basically diagonal matrices. Question number 4. Find the negative of matrices A, B, C, D and E. A is here, B is here, C is here, D, E. These are the matrices for you. Now we find their negative matrices. Here is A. To find the negative of A, we just change the signs of its elements. So here 1 becomes negative 1, 0 is same, and the negative 1 becomes positive 1. So it is a negative of A. Similarly, the negative of B can be found by changing the signs of all the elements. This plus 3 will become minus 3, this minus 1 become plus 1, this plus 2 becomes minus 2, and this plus 1 becomes minus 1. Similarly, this C matrix, it's a negative of C. The negative of C can be found by changing the signs of these elements. Here again negative d can be found by changing the signs of these elements. And here e is also found in the similar way. Now we go to the next question. Question number 5. Find the transpose of each of the following matrices. Here we have A. Transpose means that we change column into row. Here is a column and we have made a row of it. So it's called transpose. Here this one column is the first row, the second column is the second row, this third column is the third row. So changing columns to rows produces a transpose. You can do it the other way around, that is, you can also change rows into columns. It doesn't make any difference, the end result is the same. But you are not allowed to do both things at the same time. You can either convert columns to rows or just rows to columns. Only one thing. Here this first column is made into a row and the second column is made into a second row. So it is the transpose of C. Now if we want to find the transpose of D, so this first column is made into a row and the second column is made the second row. Similarly, this first column is made first row and the second column is made the second row. And the same is the case with this. This first column is the first row and the second column is the second row. So that is the transpose of F. Question number 6. Verify that if A 1 2 0 1 and B 1 2 1 0, then prove that A transpose equals A and B transpose equals B. Let's see. Taking the left hand side of this, A transpose. I have written the value of A here and taken its transpose. Taking this first column and making it a row, then taking the second column and making it a row. Now this is the first transpose of this. Now we make the second transpose, taking the first column and making it a row, and taking the second column and making it the second row. So we see that this matrix is the same as was A 1 2 0 1 and here 1 2 0 1. So it is A. So the first thing is proved. Same is the case here. We can take the left hand side of it. B transpose. I have written B here and transpose. Making the first column as the first row and second column as the second row. This is the first transpose. Again, this first column is the first row and this second column is the second row. So it again becomes B where we started. This was B 1 2 1 0. Here again 1 2 1 0. So I can write B in place of this matrix. So B transpose equals B, and this is what we wanted to prove. And that is the end of our exercise 1.2. I hope you like it, and for more videos subscribe to my channel. It's goodbye till the next lecture.